Hello everyone, I'm going to give a presentation of my dissertation. My name is Hanwen Huang and my supervisor is Dr. Paul. This is my dissertation title, Analyzing and Enhancing Content Rating for Fanfiction. So I'd like to start by introducing the background of my research. I've been diving into the world of fanfiction classification. Now, what's fanfiction? Well, it's a creative subculture where folks reimagine characters for movie, comics, or novel. It's gained a huge following, especially among young people, mostly on online platforms. So you see, fanfiction primarily lies on the internet, and its main audience is teenagers. But here's the thing, fanfiction authors upload their work themselves and decide on the content rating labels. So the labels on these platforms might not always be reliable. That means teenagers must stumble upon stuff with graphic violence more easily than they should. So what's the motivation of my research? It's very clear. I want to use machine learning and deep learning algorithms to make fanfiction content rating labels more accurate. I want those platform labels to be spot on, creating a safer online fanfiction environment. Ultimately, the objective of my research is to compare the performance of different models to tackle this issue and pick the best classifier algorithm. Along the way, I realized that trying to classify multiple labels didn't quite cut it, so I switched to a binary classification approach. Exploring both multi-class and binary class problems helps me understand how these models work on specific datasets. You will see more about this in my upcoming presentation. So I want to talk about the first step in my research, which is data collection. So all the data for my study comes from a massive online platform called Archive of Our Own, which hosts the many fanfiction works. So here's how I collect data. First, I use the web crawler program provided by Dr. Paul to scrape the data I need from the platform. Then a Java program converted this data from HTML format to TXT format. For each complete piece of fanfiction, I sliced it into different number of sentences. So this way is to find out the ideal number of sentences to use for my research, which you will read about in section 4.1 of my dissertation. The dataset consists of two components. One is the text itself, and the other is the current content rating label of the web page of each work. There are a total of 4 labels used for training the dataset, which is explicit, general audiences, teen and up audiences, and mature. Overall, gathering data for this study was quite time-consuming due to the large dataset and the need for web scraping. In my research, I mainly used the bag-of-word, TF-IDF, and word embeddings for text vectorization. Among these, BOW was used to determine the optimal number of sentences in each instance. TF-IDF was employed for machine learning models, and word embeddings were utilized for deep learning models. Using different text vectorization methods aimed to make my models more efficient for various research purposes. For example, selecting word embeddings as the vector input for deep learning models helped neural networks learn more content-related features. So this slide presents the entire workflow for content rating classification. Here you can witness how we practically apply the various text vectorization methods I discussed earlier. In the end, I employed 5 models to successfully complete the content rating classification task. Here, I'm presenting the 5 algorithms I used in my research. Among them, three are machine learning algorithms, that is SVM, naive Bayes, and the random forest. The other two are deep learning algorithms, that's LSTM and BERT. So it's worth mentioning that I applied grid search CV to fine-tune each model. These methods combines the advantages of grid search and cross-validation. So tuning the parameters was a necessary task to ensure the performance and the generalization ability for each model, as well as to prevent the overfitting or underfitting. So you can find the visualization of the parameter tuning process in my dissertation. So one key optimization focus on this task is to adjust the weak labels within the dataset, which are essentially wrong labels added by others. I employ two approaches to mitigate the impact of weak label on the models. The first method involves using the Three Sigma approach to identify and remove outliers. Consider them as weak labels, as illustrated in left diagram on this slide. The second approach entails applying LDA topic modeling to the original data. This process uncovers latent themes within the text, which are then reintroduced as the features into the training model. So the goal here is to provide the model with additional implicit text features beyond text vectors, ultimately enhancing model performance. This slide presents the key results and conclusions of my research. Using accuracy as the metric, random forest performed the best in multi-class classification problems, while SVM excelled in binary classification tasks. The effective removal of outliers using the Three Sigma method significantly enhanced the performance of all models, with BERT showing most substantial improvement. Additionally, training with topic features led to significant performance improvement across various machine learning models. Our study yields several important conclusions. The first one is that in content rating classification, traditional machine learning algorithms generally outperformed deep learning models, as you see. The significant performance improvement in deep learning models after removing weak labels demonstrates that weak labels hinder the learning process of neural networks. Ultimately, for binary classification purposes, random forest, after outlier removal, was deemed the optimal solution for this problem. Finally, there are still some avenues for further work in this study. First, using proper name detection to remove irrelevant names without information from the text can reduce the noise during model training and enhance performance. The majority class classifier can be employed to mitigate the impact of imbalanced dataset labels and serve as a benchmark classifier for comparison. To improve the reliability of certain metrics, repeated cross-validation can be utilized to enhance the credibility of results. And thank you for watching.